Hello mathematicians, this is the video for home connections 87 and 88. For the first couple of questions, we're going to use this table. Number 1 says, use the symbols greater than, equal to, or less than to compare the populations of New York City and Philadelphia. So my New York City number is 8,175,133, and I'm going to compare that with the Philadelphia number of 1,526,006. And obviously 8 million beats 1 million any day of the week. So the New York population is greater than the Philadelphia population. It says to write the population of Chicago in words. So I'm going to look at this number right here and I'm going to write it in words. So think chunk by chunk and know what to write every time you see a comma. So I'm going to write 2. And that first comma is where I say the word million. The next chunk, 695. And that second comma is where I write the word thousand. And the last chunk, 598. And always just do your best with spelling. Number 3. The city of Denver, Colorado, which is not on the list, has a population of 600,158. Write it in numbers. So it's in words. We need to write it in numbers. Let me look at that. 600. I can write that. The word thousand is where we put a comma. And the last chunk is 158. I can write that. Number 4, Seattle had a population of 608,660. Round to the nearest 10, the nearest 100, and the nearest 1,000. So we're going to round that original number in 3 different ways. So I'm going to write the original number, and I want to round it to the nearest 10. Look at the number that comes after. It's a 0. A 0 tells us to keep it the same. So I'm going to keep it a 6, make everything else a 0, which is what it already is. So this number was actually already rounded to the nearest 10. Write that original number again, and this time we're going to round it to the nearest 100. Look at the digit that comes after. It's a 6. A 6 tells us to bump it up. So I'm going to bump that 6 up to a 7. 608,700. Make everything else a 0. And again, that original number, this time rounding to the nearest 1,000. Look at the digit that comes after that, and it's a 6. A 6 tells us to bump it up. Bump that 8 up to a 9. 609. Make everything else a 0. 1,000. Letter D, fill in the bubble to show what 608,660 would be rounded to the nearest 10,000. So underline the 10,000s place. And if you look at the digit that comes after, it's an 8. An 8 also tells us to bump it up. Bump that 0 up to a 1. I see that right there. All right, page 88. Number 5 through 10, if you misread this, don't worry. They're worded maybe in a way that you're not quite used to seeing. It says, how many hundreds are in 1,000? Well, there's a 0 in the hundreds place, so if you read it that way, every answer is 0, but that's not what they mean. They mean, how many hundreds is the same thing as 1,000? Maybe think money. How many $100 bills is the same as 1,000? And here's a little trick. Within this number, if I look at the hundreds place, plus what comes before it, there's my answer, 10. You could also think, how many hundreds? Well, 100 times 10 equals 1,000. So how many hundreds are in 1,000? 10. The next one, how many hundreds are in 7,000? If I look at the hundreds place and include the number before it, the answer is 70. So it's how many 100s are in 7,000? Well, 100 times 70 is 7,000. So you would need 70 $100 bills to have $7,000. Remember, for these last two, you could think 1 times 1 is 1, 3 on the left to match the 3 on the right. Or 1 times 7 is 7. 3 on the left to match the 3 on the right. All right, the next one. How many hundreds are in 10,000? So I'm going to look at the hundreds place and include everything before it. And the answer would be 100. And let's see if that works out. 100 times 100. That equals 10,000. 1 times 1 is 1. 4 on the left to match the 4 on the right. So you would need 100 $100 bills to have $10,000. Number 8, how many thousands are in 38,000? There's the thousands place. So there's my answer. And I think that should make sense to you just with your ears. How many thousands are in 38,000? There are 38 thousands in 38,000. Or you could think 1,000 times 38. And that is 38,000. So you could think 1 times 38 is 38. 3 on the left to match the 3 on the right. Number 9, how many 10,000s are in 200,000? So let's look at the 10,000s place and include what comes before it, and that's an answer of 20. So you would need 20 $10,000 bills to have 200,000. And you could think 10,000 times 20, which is what the answer is, and let's make sure that that does indeed equal 200,000 like it's supposed to. 1 times 2 is 2. 1, 2, 3, 4, 5 on the left to match the 5 on the right. And the last one, how many 100,000s are in 5 million? So look at the 100,000s, please, and include what comes before that, and the answer is 50. And let's make sure that if we had 100,000 and we did 50 of those, would it equal what it's supposed to? 1 times 5 is 5. 1, 2, 3, 4, 5, 6. 6 on the left to match the 6 on the right. Okay, number 11, greater than or less than, greater than, or equal to. It's very important that you make both sides the same unit, and then they're crazy easy to compare. It's like in fractions when we said, if the denominators are not the same, make them the same. Same thing with comparing measurements. If you make them both have the same unit, they're easy to compare. There are 1,000 meters in a kilometer. So 18 kilometers is the same as 18,000 meters. Now it's super easy to tell which one's bigger. 20,000 is bigger. There are 1,000 grams in a kilogram. So 17 kilograms is 17,000 grams, which is definitely bigger than 1,700. And the last one, 13 and a half liters. Well, a liter is 1,000 milliliters, right? Like 1,000 drops. And then a half a liter would be another 500. So this would be 13,500 milliliters. Put that up here. And I can see that that's exactly the same as the other one. So this last one should be equal. Number 12, during his practice this month, Jeff ran one 10K in 1 hour, 1 minute, and 49 seconds, and another in 57 minutes, 53 seconds. How much faster was his second one? Show all your work. So you can use a number line. I will also show how you can do a subtraction problem. You do not have to do both. You can do whatever one is your favorite, and that might change depending on the situation. I'm going to start at my lower number, 57, 53, and I'm going to jump up to my higher number, and that will tell me the difference between the two. You can jump in all sorts of different ways. I'm going to jump 7 seconds because that'll put me at a nice even number, 58 minutes. Then I'm going to jump another, I think, 2 minutes, which will put me at 60 minutes or 1 hour. And I'm supposed to be jumping up to 1 hour, 1 minute, 49 seconds. So I'm going to jump up, I think I'll break it up and jump 1 minute to get to 1 hour, 1 minute. And then finally jump another 49 seconds. And that'll put me right at the other time for Jeff. Okay, so from jumping from the lower number to the higher number, the answer would be adding all of our jumps together. And if you jumped in a different way, that's totally okay. We should end up with the same answer. So 2 minutes plus 1 minute is 3 minutes. And 49 seconds plus 7 seconds is 56 seconds. So 3 minutes, 56 seconds. But I'm going to show it with a subtraction problem as well to show that you can also do that. All right, so I'm going to start at my bigger number, 1 hour, 1 minute, 49 seconds, and subtract the smaller number, 57 minutes, 53 seconds. Remember that the most powerful number in time is 60. So before you can subtract like normal, you have to do a whole bunch of regrouping. So I cannot do 49 minus 53, so I'm going to take one of these minutes, and that minute is the same as 60 seconds. This is a little bit crazy. If I add 60 plus my 49, that's 109 seconds. Now I can subtract 109 minus 53. And I get 56. I cannot do 0 minutes minus 57 minutes. You can't do 0 minus 57. So I'm going to take this hour, and I know an hour is the same as 60 minutes. And now I can do it. 60 minus 57 is 3. And I can see that I get the exact same answer this way. And it doesn't matter which way you like better, but you get the same answer. All right, last one. Alex bought a 6-pack of sport drink bottles that each had a volume of 350 milliliters. If he drank 3 of them, or she drank 3 of them, how many milliliters? So I'm going to do 350 times 3, or 350, 350, 350. 1,050. And letter B, how many more milliliters, I know that's a subtraction problem, would Alex need to drink to have 2 liters? You need to know that 2 liters is the same as 2,000 milliliters minus the number we just figured out. And I need to subtract. Make this a 10. Add a 9 to make this a 10. Okay. 950. All right, kiddos. Here are the answers to 87 and 88. And I will see you in class.